Hello everyone, good evening. Welcome to the solutions for BSDS sample paper 2024. Now we have done till question 12. This is question 13 and question 13 is a problem on probability. Okay, so this question relates to the Bayes theorem and I found a very similar problem like this in a different book. So I have written down half the solution and I'll explain to you the later half from the data that is given to this particular sum. Alright, so what do we have in the question? The question says that suppose there are two buckets. Bucket 1 contains 2 red, 3 black and 5 white balls. So bucket 1, how many balls are there? Bucket 1 has 2 red, 3 black and 5 white. So 10 total. 10 balls total. Right? And bucket 2, this has 3 red, 4 black and 2 white. So 3 plus 4, 7 plus 2, 9 balls. Alright, remember this. Now, why do you need to remember this? Because we are going to be transferring balls from one bucket to the other, right? So you have to keep the total number of balls in the denominator while you are calculating the probabilities of each event, right? Now, please be very careful that this word is bucket 2, all right? This 2, the numerical value of 2 does not appear anywhere in the sum, all right? So when you are reading the sum, please do not be so quick that you are adding this 2 in the total number of balls. All right, so bucket 2, the 2 has nothing to do with the sum, so please be very careful about that. While I was trying this sum in rough space, I actually added this 2 in the total number of balls and I started working with 11 balls, which got me a very different answer. Alright, so be very careful about that. Bucket 1 contains 2, 3 and 5, so 5 plus 5, 10, and bucket 2 contains 3, 4 and 2, so 3, 4 plus 2 is 9. Alright, now let us define the events. Event A would be drawing a white ball from bucket 1 and event B would be drawing a black ball from bucket 2. Okay, so we want to find the condition probability PA given B. Alright, so given that we had drawn a black ball from bucket 2, we have to find the conditional probability PA given B. Alright, which represents the probability of drawing a white ball from bucket 1 given that a black ball was drawn from bucket 2, right? Because it is given here if this ball is black. Alright, because that is the ball that was drawn from bucket 2. Alright, so please make sure that you translate the sum exactly to the assumptions that you have made. Now the Bayes theorem is this, right? PA conditional B is equal to PB conditional A into PA by PB. Alright, now we need to calculate each of these probabilities on the right hand side and then we can plug the values in the final equation and calculate it. So first let us calculate PA. What is the probability of drawing a white ball from bucket 1? Now PA will be, how many white balls are there in bucket 1? 5, and total number of balls will be 10 that we have calculated right there on the top right hand corner. So white balls by total balls, so that will be 5 by 10, which is equal to half. Now probability of drawing a black ball from bucket 2 given that a white ball was drawn from bucket 1. Now a white ball was drawn from bucket 1 and put into bucket 2. So the new number of balls in bucket 2 is 10, right? 9 were there previously. Now you have drawn a white ball and put it in bucket 2. So the probability will now change to, the total number of balls will now change to 10. So the probability of B given A, that will be, what is the number of white balls originally? 2, right? And you will have a total of 10 balls now, so this is 1 by 5, right? Now we have to calculate probability of B. So the probability of B is basically, let me check, 3 red, 4 black and 2 white. Yeah, correct. Okay, probability of drawing a black ball, right? So how many black balls were there? 4 black balls, so it won't be 2, it will be 4. Yeah, that is why it looked a bit weird. So 4 by 10, which will be 2 by 5. Alright, now we have to find the number of black balls in bucket 2 irrespective of which bucket the ball came from. So we don't know where the ball came from, right? Now what will be the probability of drawing a black ball then? It will be still 4 by 10, right? Because even if we do not know which bucket the ball came from, one ball was still added to bucket 2, right? And the total number of balls in bucket 2 will be now 10. And what is the number of white balls there? Sorry, number of black balls there? It will be 4, right? So it will still be 4 by 10, which is equal to 2 by 5. I hope you could understand this. Probability of drawing a black ball from bucket 2 given that a white ball was drawn from bucket 1. Here bucket 1 is specified. As it is drawn from bucket 1, then we can clearly say that it is 4 by 10. But if we do not specify that whether if it is drawn from bucket 1 or bucket 2, doesn't matter. Whether it was originally in bucket 1 or whether it was originally in bucket 2, doesn't matter. If a ball is added in bucket 2, the total number of balls will be 10. Alright, and then the probability of drawing a black ball would be 4 by 10. Okay, so now you calculate the condition probability. That will be P A given B. That will be equal to PB conditional A, that is 2 by 5, into PA, which is half, divided by 2 by 5. So 2 by 5 will cancel out and you will end up with half. So the solution is option B. Okay, I hope this is clear. I just changed the formats of the sum from a written technique to a conditional technique, and then I represented each of the events as and when they occur. I calculate the conditional probabilities, and then finally I substituted the values in the Bayes theorem and calculated the correct answer. Alright, so please make sure that whenever you are doing this type of sums, you define the events correctly, because as long as you define the events correctly, you will get the correct values and solve the sum. Okay, so again, a straightforward sum. Once you know the Bayes theorem, you remember the formula, you can identify the particular events, you will do this quite easily. Alright, so I'll be ending this video here. We will meet again in question 14.